Hello class, this is a video tutorial on the transformations of functions part 2. In this video we'll be looking at the completed square form of a parabola. This is also known as the vertex form. Vertex form of a parabola. By applying horizontal and vertical translations in combination with properties of parabolas, we can quickly determine the vertex of a parabola. So, by first translating the parabola y equals x squared, determine its vertex. Before we even continue, a quick sketch of this parabola. We know it should look like something like the following. Like so. And we already know that this vertex here is going to be at 0, 0. Let's take a look at what happens to the vertex as we do some translations to this vertex. Okay, so shifting this entire function down, well, that's as simple as taking the function y equals x squared, and shifting down means going downwards by 3, which is minus by 3. Now if we think about it like this, it's moving the vertex 3 spaces down, which means the vertex will be somewhere here. Well, if we're only moving down and not moving left or right, that means the vertex of this is very easily found at 0, 3. If we're shifting to the right 4 spaces, we're letting x equal x minus 4. So we're going to let this become y equals x minus 4 squared. So now considering this position here, it's moving 1, 2, 3, 4 to the right like this. Okay, so that there, well, we're only moving the x-axis. So that means the vertex of this, if it was originally 0, 0, we're moving 4 spaces to the right. This 0 should now be 4, and the y-axis hasn't moved. Sorry, the y value hasn't moved, so it's still 0. Shift it up 2 spaces and left to 3 spaces. To shift up 2 spaces, we take the function and we add 2 because it's moving the function up. And to move left 3 spaces, we let x become x plus 3. So applying this to our function, this one here, we will get y equals, we're replacing x with x plus 3. So x with x plus 3, this will become squared. Then moving the entire thing up 2 spaces. Now, just to draw this again, here is the original function in orange. If we were to move this function up 2 spaces, then it will go up here. Oh, actually no, before we go on, this will now be 0, 0. If we move the function up 2 spaces, it will now be here, which means its vertex will be at 0, 2. But we also moved it 3 spaces to the right. So 1, 2, 3. So its vertex will now be here at negative 3, 0. Combining both of those, our function, our graph should be up here somewhere. And its vertex will be at negative 3, 2. Do you notice any patterns that's happening with the function in the translations to its vertex? Well, in case you didn't notice it, if we have the function f of x equals x minus h plus k, the vertex of this function will be at, no, not a circle, the vertex of this function will be at h, k. So for example, if we had, sorry, this should be a squared. If we had the function f of x is equal to x minus 2 squared plus 3, this value here is going to be, whoops, well, our h value here is 2, so our vertex will be at 2, and whoops, and our k value is also 2, so it's going to be 2. If we had the function equaling x, let's say plus 5 squared, let's move this out of the way to get some more space, plus 5 squared minus 7, the vertex will be at negative 5, negative 7. So these two values will help us determine where the vertex is. So by converting to completed square form, determine the vertex of the following parabola. Okay, so what we're going to be doing is we're going to be completing the square on just this portion here. Let's take a look at what this will look like. Y equals x squared minus 6x. I'm going to move this across here, plus 8. Now to complete the square, we take half of this, which is negative 3, and we square it. Negative 3 squared is plus 9. Now, normally, when we add 9 to the right hand side, we add to the left hand side as well. This time, instead of adding plus 9 to this side, we're going to subtract 9 on the same side. Let me do this in black so you can see it, because this balances the equation. So when we add 9 and then subtract 9, so nothing is really happening to this equation. But the reason why we do this is now this is a perfect square. This will be x minus 3 all squared. And this, when we evaluate it, 8 minus 9 is negative 1. And from this form, we can quickly identify the vertex of this parabola to be 3, negative 1. Let's do this again. Y is equal to x squared minus 4x, moving negative 5 to this side. We take half of 4, which is negative 2, and we square it. Negative 2 squared is plus 4, and here we minus 4. Oops. This gives us, so we're going to factor this one now. This becomes a perfect square of x minus 2 squared minus 9. And from here we can quickly identify the vertex to be 2, negative 9. Let's do this one more time. Take the function x squared plus 2x minus 8. We take half of this value of b, we square it, so half of 2 is 1. 1 squared is 1, so we add 1 here, but we subtract 1 on the same side of the equation. This factors to become x plus 1 squared minus 9. This tells us the vertex is at negative 1, negative 9. So I hope that gave you an insight into the completed square form or the vertex form of a parabola. Hope to see you in the next video. Best of luck.